Okay, I'd like to introduce our first keynote speaker of the day, Eric Siegel. Eric Siegel is the founder of the Predictive Analytics World Conference series, so you can check out his website and learn more about what's going on there, but a very popular program within the context of the predictive analytics industry. And he's also the author of Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die. I'd like to welcome Eric.
Very much. I have a lab, so it should be cool without that. Thanks very much. Thanks for everyone for coming. It's a pleasure to be here. So we're talking about prediction. Prediction as a capability should be the holy grail for targeting marketing, for targeting the inspection of individual items, for defects or for breakdowns in manufacturing and maintenance, for targeting individual transactions for their potential to, targeting the inspection of them for their potential to be fraudulent, and just so many different kinds of operations across the enterprise that could potentially gain value and become more effective in mass operation by applying these individual per item or per person predictions. So the value is clear for this idea of prediction, but isn't prediction supposed to be impossible? Like the only thing certain is uncertainty. The weather can only be predicted so far ahead, and human behavior in the case of marketing applications or the behavior of items and products, no less challenging to predict. So how do we put credibility on a field that has the audacity to call itself predictive analytics? That's a credibility question that I'll address partway through my presentation. So a couple slides about my work. As you just heard, I'm the founder of the Predictive Analytics World Conference series. We're the leading cross-vendor event focused on commercial deployment of machine learning and predictive analytics. And we have individual vertical events, most of them together this year as far as our main North American event in Vegas in June, including our umbrella business event, including marketing and other applications and financial services, its own event, Predictive Analytics World for manufacturing, for healthcare. All of these things are together under one roof this June in Vegas. I'm also the executive editor of the Predictive Analytics Times. Check out predictiveanalyticstimes.com. It's basically a news portal, lots of content, including full-length session videos from the Predictive Analytics World Conference. And you just heard the title of my book, and I'm going to read the full, long title of my book again because the subtitle actually serves as a starter kind of informal definition of the field. So it's Predictive Analytics, the power to predict who will click, buy, lie, or die. So we're talking about rendering these predictions per individual. So just and I actually have 4 copies of the book with me. So the first 4 people to approach me after this talk, there's a coffee break. And during that, the first 4 people to rush up to me and say, predictive analytics is cool. And you can't say predictive analytics are cool because it's singular, like statistics. Statistics is cool, but not as cool as predictive analytics is. So if you say that, you'll get one of the copies of the book. So here's my elevator pitch for the book. I'm a former academic, and as such, this is a conceptually complete intro used as a textbook at more than 35 universities. But doesn't read like a textbook. It's very much sort of the pop science mode of sort of anecdotally driven, relatively entertaining, accessible book, able to be understood by any reader. But for those of you who are experts already in the field, good sort of industry overview, new case studies, and treatment of advanced topics in the last 3 chapters of the book. And for those of you who might be tweeting today, or would like to follow me, my Twitter handle is PredictAnalytic. So I'm going to talk about predictive analytics, define it, what it is, and focus for many of the examples on marketing applications as an exemplar for the industry value that you get from deploying these machine learning methods known as predictive analytics, specifically in targeting acquisition and in targeting retention of existing customers. Then we'll talk about a broader set of applications, including in manufacturing and automotive. I'll look a bit under the hood. We'll see how it works, what a predictive model looks like, talk about its benefit to the organization in terms of these two effects, prediction effect and the data effect, and cover some case studies along the way, not exactly linearly the way I have it laid out in this slide. So what's predictive analytics? How many people here have heard of, are familiar with Nate Silver? Okay, most people. So there's no better known person of prediction, no more famous prognostic quant than former New York Times blogger, sports predictor, and political poll aggregator Nate Silver, who gained a lot of fame specifically in the 2012 US presidential election for correctly predicting the outcome for each individual state during that national election. So things were a bit different in 2016. This was his overall prediction towards the end, showing a 71% chance of Clinton taking the election in 2016. Now, as I mentioned a second ago, prediction is hard. But in fact, this is a relatively conservative prediction. Lots of people in media and at home watching TV took these numbers and said that means Clinton's got it in the bag. You know, it's like it's a passing grade. So if you get a 71%, you know you'll pass the class. It's a definite thing. It's virtually a sure thing. But that could be further from the truth. But it's far from a sure thing. 71% is closer to a 50-50 toss-up than it is to a 100% sure thing. The main takeaway from that number in this context is 71%. Right? And that's not the prediction of how many people would vote. That's the prediction of the probability that Clinton would win. But since it's closer to a 50-50 than a sure thing, the main takeaway is, I don't know, is the uncertainty, is the difficulty in that context. So in comparison to some of the other predictions, Nate Silver's model was actually relatively conservative. In any case, in making these predictions, and in particular per state, you know, people wonder, is that predictive analytics, or did he use predictive analytics? And in fact, the answer is no. But in 2012, Obama did use predictive analytics. And this is a perfect way to illustrate the difference between predictive analytics and forecasting. So what Nate Silver does is forecasting for an individual state like Ohio, what's the overall aggregate trend going to be across voters? In 2016, for example, the prediction was that across all voters, there was a 35% chance it would end up being more than half for Clinton. So it's not on the per voter level, it's sort of the overall for that state. Whereas, in contrast to that, the Obama, in 2012 at least, the Obama campaign analytics team rendered a predictive score for each individual voter, and not the way I've just popped up on the top right. In fact, they used a more advanced form of predictive analytics. So rather than predicting which direction each person would vote for, they voted, they predicted, could this person's vote be influenced? Are they persuadable? Are they influenceable by way of a knock on the door by a campaign volunteer or a phone call from a campaign volunteer, targeting direct mail very much the same way? Doing all this to render that sales force, a political campaign is a marketing campaign, and that the sales force in this context is the army of volunteers, and rendering that army much more effective, much stronger by targeting its efforts towards those predicted most likely to be persuadable to drive voting behavior. Same concepts apply to driving commercial buying behavior. So in a nutshell, Nate Silver competed very publicly, he was on all the talk shows, to win at predicting the outcome of the presidential election, while at the same time, the Obama campaign analytics team competed very secretly and quietly to win the election itself, right? So which is more powerful? In other words, with that defining difference from forecasting, that predictive analytics renders a prediction per individual, that means it empowers your organization not just to predict the future, but to influence the future by way of rendering these types of mass scales operations in marketing and beyond that much more effective en masse. Now, we have reason to believe Hillary for America also applied similar techniques that the Obama campaign did. But even if they did, obviously it wasn't enough of an improvement to the effectiveness of the campaign to win. But in business applications, you don't normally have the same type of winner-takes-all dynamic. And very much businesses in general are super duper jumping on the bandwagon with the predictive analytics market forecasted to be at $6.5 billion within a couple of years, ranked as the #1 priority of chief information officers. LinkedIn creates a hottest skills that got people hired list every year, and in recent years it's been the #1 and #2 slots. So I like to call predictive analytics Moneyball for money. I thought that was pretty funny. So much so, people are calling it sexy, right? There's this famous 2012 Harvard Business Review article, Data Scientist, the Sexiest Job of the 21st Century, which was written by Thomas Davenport and DJ Patil. Thomas Davenport wrote the foreword to my book. DJ Patil actually was subsequently appointed by Obama to be the first chief data scientist of the US. And I do consider these two guys very handsome. But as far as sexiest job, I always assumed that was reserved for firefighters. I know it's a hard hat, maybe, like that. That's me dressed as a data miner for Halloween. It's not, it doesn't. Actually, firefighters use predictive analytics to triage and prioritize the inspection of buildings most at risk for fire. And Con Ed does this analogously, the same thing, for targeting and triaging inspection of manhole covers for dangerous incidents such as fire and explosions. So anyway, back to the sexy stuff. We made a rap music video about predictive analytics, which is, and I'm just going to make a bold claim here. This is the best ever educational rap music video about predictive analytics that's ever been made in the history of civilization. It might be the only one. The lyrics are educational. The video is sort of about what does it do to your social life to be in the field of predictive analytics. But it has a happy ending. It's only 3.5 minutes long. And check it out at predictthis.org. Okay, so here's our more complete definition. Predictive analytics is technology that learns from experience. And so by experience, I'm referring to data. How many people here get excited when you think about data? Ooh, good. You're my people. It's not necessarily a representative sample that we have here in the room today. You know, a lot of times people think data is kind of boring. It's kind of a deal killer at cocktail parties, I found. I know from personal experience. I have the data. Somebody got the joke. But that's because people very quickly forget that it's not just a bunch of arcane ones and zeros. Data is a recording of things that have happened. It's a list of prior events. It encodes the collective experience of your organization, from which it's possible to learn from it, to derive a predictive model, ascertain rules, or other types of patterns, mathematical formulas, different ways to represent it, but you're learning from it in order to render these predictions per individual. So each individual, which could be a person, but also could be a manhole cover, a building, an automobile, or a component, or whatever it is. On the individual level, that's the defining characteristic, right? And the higher the number assigned, the higher chances that the individual will click, buy, lie, or die, like in the title of my book, commit an act of fraud, break down, turn out to have a defect, have a fire, any and all possible outcomes or behavior for which it would potentially be valuable for your organization in order to target the treatment or action towards that individual, such as should I spend $2 sending them a brochure, should I knock on their door, should I inspect it, or whatever it is. So just one slide here on vocabulary. For the most part, predictive analytics and machine learning are actually synonymous. Until pretty recently, machine learning was really just strictly the academic term for the same thing in research labs and such. They both referred to the use of the same core analytics methods or machine learning algorithms like decision trees, neural networks, which includes deep learning, ensemble models, and lots of other sort of competing methods. Oftentimes you try different ones against one another, see which works best on your data. When you apply these in the business world, it's called predictive analytics. These are mostly overlapping. In most contexts, they're synonyms. And both of them are subsumed by these broader fields, big data, data science, which in and of themselves are more subjectively defined. They basically mean they don't necessarily allude to any particular algorithm or method. They include other things like potentially forecasting and all other kinds of clever things, market mix modeling. And they're basically alluding to a culture of smart people trying to do smart things with data to get value from it. And the same thing could probably be said about the older school term data mining. So in a nutshell, the core technology takes data as input, predictive modeling, and produces what I show as a golden egg in these slides, which is the predictive model. That's the thing you've learned from the data. That's the rules or whatever generalizations you've captured from the data. And then it, in turn, now serves to render these predictive scores or probabilities or however you want to think of them per individual. So it takes as input after the learning is done, right, when you go to deploying it, when you're actually using it, it's rendering the score per individual for whatever it is you're trying to predict in this particular project. So in marketing, you're looking at a customer today, you're saying, should I expend the $2 cost of contact in this marketing treatment? If I do, what are the chances that tomorrow I'll have the positive outcome and they're going to buy my sneakers? So as I mentioned, prediction's hard. Nobel Prize winning physicist Niels Bohr, prediction's very difficult, especially if it's about the future. Jay Leno, how come you never see a headline like psychic wins lottery? Right, good question. Okay, so this is the big answer to my opening question about credibility. Who are we to say we can predict the future? It's really simple. The bottom line that makes this stuff valuable is you don't need to necessarily predict accurately in order to produce value. Predicting better than guessing and tipping the numbers games, tipping the odds in your favor in all these different kinds of mass scale operations, because numbers is a business game, is generally more than sufficient to have a dramatic improvement on the bottom line, return on investment of a marketing campaign and what have you. So let's do a quick back of the napkin arithmetic example to exemplify that. Say we're doing mass marketing to 1 million people, it costs $2 per contact, so I'm going to spend $2 million to contact everybody. This is before I do any machine learning. I'm just going to do mass marketing to everybody. So it's going to cost me $2 million to contact everybody. If I get a 1% response rate, I'll get 10,000 responses. And if I get $220 for each one of those, well, for the 10,000, 220, so I'm going to get 2.2 million of revenue in after spending 2 million out. So my bottom line is 0.2 million profit, $200,000 profit. So now, how much better would it be? How much of an improvement would I get on the ROI of the marketing campaign if I use predictive analytics and target predictively? Well, let's say I took a sample of like 40,000 random individuals and did a test marketing campaign to them, and I collected all the yeses and nos. That is the results. I waited to see who did convert or did buy and who didn't. So then, now I have experience from which to learn, which is literally the technical term for that, training data. So it's the situations that I don't have to predict, but they've already happened in the past. But they're the learning cases. I do the number crunching, create that golden egg, and then score all 1 million of these customers and order it, list it from top to bottom, most likely to buy if contacted, down to least likely. And then if I just take the top 25%, the top quarter, 250,000, most likely to buy if contacted according to the model. Well, if machine learning has done a pretty good job, I might get what's called a lift of 3. So within that top quarter, I might have 3 times the response rate of average, so a 3% response rate. instead of an overall 1% response rate. So this hot pocket has a multiplier of 3. So that's great. That's a lift of 3. So now the arithmetic I did a second ago, if I do the same thing but just apply it to this smaller campaign that's only 25% of people, that of course means I'm going to save, relatively speaking, 75% of the marketing costs. Now I'm going to lose some of the business in those 75% that I don't contact at all, but I've got a much higher concentration of the buyers in this top 25%. So the trade-off sounds like a pretty good thing. If you do the little arithmetic on your calculator watch, it turns out that the bottom line profit skyrockets by a factor more than 5 to $1.15 million. Such a dramatic improvement just by more intelligently targeting your existing marketing creatives for your existing products without any other changes. That I actually paid my graphic designer, who I pay by the hour, to draw this star explosion thing to emphasize the significant improvement we got there. But hold on a second, this model totally stinks, at least from a lay person or a general casual use of the word accuracy. 3% response rate. That doesn't give me any high confidence that any one individual is definitely going to buy within that pocket. It's a 3% response rate. But the value is unquestionable, so we could alternatively define predictive analytics as a skunk with bling. That would be you're not writing that down? So I call this the prediction effect. A little prediction goes a long way, rendering mass scale operations more effective by deriving all these per individual decisions by those per individual predictive scores or probabilities. So now let's turn to how it works and take a look under the hood a bit, what the data needs to look like. How many people here saw this movie, Kung Fu Panda? Oh, good, a lot. How many people saw the movie and don't have kids? We should hang out. So the old wise turtle, Dustin Hoffman, does the voice. Yesterday is history, tomorrow is a mystery, but today is a gift. That's why it's called the present. This is my meditation fingers. But to take a slightly less, sentimental and humorous look at it, pragmatically, what do we have here in the present now as a resource that's going to help us with this sort of unveiling some of the shroud on this ultimate unknown, which is the future? You're looking at the customer today, you're saying, should I expend the cost of contact? What's going to happen tomorrow? That's unknown, but I have these two things that have the same relationship with one another that are known, which is yesterday versus earlier today. Now, both things are in the past. Let's say yesterday I contacted the customer and found out earlier today they did convert, they bought the product. So this is all in the past, no prediction necessary. It's a learning case, learning example, one row of data in our training data. Everything to the left of the dotted line is what you knew at the time you would have liked to make some kind of prediction. Any and all demographic and behavioral data about the individual that could help tip the balance on the odds. So the person's male, lived in California, had made at least 10 purchases, et cetera, et cetera. And then on the right of the dotted line, also in the past, but in a different time, it came later, is the outcome, the thing that we'd like to predict. And if that's one row of data, what you need to do is get your data into that form and format and just put a bunch of rows. So that's 80% of what you need to know about the data requirements to do predictive modeling. It's not rocket science, but it's by far the most challenging, time-consuming part of the hands-on project. Because getting your data into that form and format, and it's also called a BOF, big old flat file. It's just two-dimensional. It could be written on a big piece of paper, Excel spreadsheet, or a database view, or whatever. But getting it from the way your data looks now and how it's distributed across tables and silos and such, into that form and format, with the idea of time, so that what's on the left of that dotted line is only what you knew back then. You can't cheat and have things that came later influence that. So getting it right, that's sort of a major database programming challenge. And typically considered 80% of the hands-on production time for any machine learning initiative, at least in the first pass. Any new machine learning initiative. Anyway, once you get it into that form and format, and you've got lots of rows, so it's probably a very long table and also potentially much wider than I'm showing here, because many things known. You get all these insights. For example, people who go to the bar are higher credit risk. So let's go through a few examples, types of insights you get from data. Canadian Tire issues credit cards and looks at how people spend with a credit card relative to, on the right of that dotted line, the prediction goal. Are they good credit risks? To be specific, do they pay their credit card bill on time? It turns out that people observed spending with that credit card at a drinking establishment more likely than average to miss repeated credit card bill payments. Whereas people who are seen spending at the dentist are actually lower credit risk. And people who buy little felt pads and don't scratch the floor with the bottom of their chair. How many people here buy little felt pads? You don't? Oh, good. You got it together, people. You're my people. I've never bought those pads myself. I really should get on that. Lower credit risk. People who like curly fries on Facebook are more intelligent. Men who skip breakfast have a higher rate of coronary heart disease, not necessarily because of the meal, so it's not necessarily a causal relationship. That's considered a proxy for lifestyle, living a fast-paced, high-stress life, more likely to be skipping breakfast, also more likely to be leading to coronary heart disease. Certain neighborhoods in San Francisco that exhibit higher rates of certain crimes also exhibit higher demand for Uber rides. Uber published this result and then took it down, but it's the internet. It's the internet, so it's still there somewhere. And it's linked. By the way, I provide the event a PDF of the slides, and about a third of my slides or something have additional links or notes in the notes section. So I make the PDF so it includes the notes sections, including this one, going to the link that Uber doesn't want you to see. Not necessarily because the criminals are riding in Uber, but because that turns out, and this had been actually their hypothesis before they did the analysis, that's a proxy for non-residential population. In other words, those are the areas of at least San Francisco where there tends to also be more people who don't actually live in that neighborhood for whatever other commercial reasons or whatever's going on. So there's a difference between correlation and causation. I'm going to come to that in a second. But in any case, the data speaks. We need to translate it, learn how to listen to it by doing this type of analysis. It says dental patients miss fewer credit card payments. And I call this the data effect, which is that for all intents and purposes, data is always predictive. That's the big in big data, is the big value of the fact. I mean, size is great. The data is growing so quickly, but we're going to run out of adjectives. I mean, there's been a conference called the Very Large Databases Conference since like 1983 or something like that. Big, bigger, biggest, right? It's always, doubling in size. But qualitatively speaking, what's big is that it's predictive because it encodes experience from which to learn, right? Not necessarily learn about causative relationships, but learn how things are linked or correlated in a way that helps build these predictive models and predict. In terms of this correlation versus causation thing, I'm sure most of you have heard this expression. Correlation does not necessarily entail causation. So, for example, you could easily see in the data a correlation, a link between ice cream consumption and shark attacks. And then if you want to say, well, why is that? You could conjecture a causal explanation. Say maybe that's because when you eat the ice cream, it makes you taste better. So you eat the ice cream, and then the shark eats you. But the more widely accepted explanation is that it's seasonal, so when the weather's better, more likely to go swimming, also more likely to be eating ice cream. So that is to say that these two things that are linked into the data, that are correlated, and therefore one helps predict the other, are not, in this explanation, causally linked in either direction, even indirectly. Now so they're both caused by this third factor, and that whatever that third factor is, it may not, for whatever reason, have been collected or thought of, or just may not exist as what would really be a column or a variable in your training data. So this is a sticking point, right? The difference between correlation and causation, because as humans, when we see these links, we want to make explanations. We latch on to something, oh, that seems intuitive, and you think you know how it works. You have to remember that those are just conjectures. Generally, from this type of analysis, you don't get conclusive information about the why, i.e. the causation. But you get the correlations, they help predict, that's fine. On a sort of related note, sort of reversing it the other way, sometimes people come up with causal explanations to help believe in things that are actually not true. So the Seattle Times actually ran this, and many other publications, that orange used cars are better to buy. They're less likely to be lemons, that is, to be unsatisfactory used car buys that break down. So if you're considering buying a used blue car, change to an orange car, it's a better deal. It turns out that that was BS science. So bologna sandwich, also known as bad science, it was subjected to a fallacy, a spurious pitfall in analysis called p-hacking. Even John Oliver covered p-hacking on his show last week tonight. You can watch the video, I linked it. I also linked a whole bunch of other stuff. We don't have time really to get into that, it's a whole nother talk, but I did link an article I wrote, which is an excerpt, if you have my book, of second edition of chapter 3. So the thing is that people thought, oh, gee, the orange cars, why would the color of the paint make a difference? And then they came up with these causal explanations. It's because people who have a wacky color for their car are sort of, psychologically, they're more sort of invested in their car and they take better care of it and this kind of stuff. Now, it may be true that orange cars are better, but the problem is in the data that we have, in this case, the data came from a Kaggle data science public competition, it's not conclusive. So and you can be subjected to this pitfall called p-hacking, and if you want to learn about how to avoid that, check out the article I linked to. In any case, in general, you avoid that by having a separate test set, and if we have time for Q&A, I can get to that more. It's generally, that pitfall is not an issue. When you combine multiple variables with these models and deploy it, here's some marketing examples. First, Tennessee Bank lowered the direct mail cost by 20% and increased the return on investment of their targeting marketing, of their marketing campaigns, direct marketing, by a factor of 6 by moving to machine learning targeting. Target does target their marketing, improved by 15 to 20%. Premier Bank Card, major issuer of credit cards, reduced their mailing costs by $12 million. It's not just large businesses, so I'll just mention the second of these three, still in the marketing examples. Small business that sells candy, Harbor Sweets, was actually able to create a marketing creative to try to win back lapsed customers who they hadn't seen for a while. And with the targeting from machine learning, we're able to earn a whopping 40% response rate. So what I've been talking about so far is sort of this driving marketing treatment decision, the treatment of the customer, and choosing in those treatments between an active and a passive treatment. That is like Hamlet, to contact or not to contact, that is the question. But there's plenty of cases where there is no passive treatment. Like if somebody comes to your website, you're not going to show them a blank page. If they call customer service, how are you going to respond? They ask for a price. There's plenty of cases where the treatment choice is between only active options. So for example, that's what you're doing in A/B testing. So here's a nice little example of A/B testing. A psychologist in Arizona put up a sign in the Arizona State National Petrified Forest where they have fossils. And people were stealing the fossils, the small ones, not those big ones, but they were putting the small ones in their pockets. Please don't remove the petrified wood from the park in order to preserve the natural state of the petrified forest. And then in a head-to-head comparison, basically like an A/B test, the psychologist tried this alternative. So the rate of theft that result was less than 2% when that sign was put up. And then in the head-to-head test, they tried a different language. A little more dire in the wording here. Many past visitors have removed petrified wood from the park, changing the natural state of the petrified forest. This is having an impact. The thing is, from a psychological standpoint, this actually had the reverse backfiring effect because it implies everyone's doing it. It sort of kind of gives people license, and more than 4 times as many people, almost 8%, were stealing the fossils. So it's obvious which of these two messages would be better to put up. Put up the prior message. It's going to lower the overall theft rate. That's A/B selection, essentially, like you might do on your website. But it's not personalized. It's not predictive analytics. There may be some individuals that would be more receptive to this message. Depends on factors that you might know about the individual that could help you predict which message. So it may be that if you're more able to make a per-person, personalized prediction for each individual, to get the theft rate even lower than the 2% on the other one by selecting between these two or maybe between more than those two. That's what we're trying to do in general, including within our own personal dating life, right? Let me just be your dating coach for a minute. You're in the restaurant, and just so you know, I don't know if you haven't thought this through, you're not actually in the restaurant for the food. It's a sales call. You're the director of marketing and the product. It's very important to choose ahead of time, predict which treatment to the prospects most likely to lead to a positive outcome. How many people saw this movie Groundhog Day? Okay, most people. Yeah, good movie, yeah. So Bill Murray's stuck living the same day over and over. He hates it. But then he recognizes it provides for him this unprecedented superpower to test different marketing treatments on the same prospect under exactly the same circumstances to see which leads to the positive outcome. Let's watch a 47-second clip from the movie Groundhog Day.
You weren't in broadcasting or journalism?
Mm-mm. Believe it or not, I studied 19th century French poetry.
What a waste of time. I mean, for someone else, that would be an incredible waste of time. It's so bold of you to choose that. It's incredible. You must be a very, very strong person. Yeah? You weren't in broadcasting or journalism, anything like that?
Believe it or not, I studied 19th century French poetry.
La fille qui j'aimerais sera comme bon vin, que c'est bon fuira un peu chaque matin.
You speak French.
Oui.
Do not try that at home. So the sad news is that we can't do this at home because in real life, there are no do-overs. The only recourse is prediction a priori, which is going to lead to the positive outcome. In marketing, there's 2 main application areas of predictive analytics. What I've been talking about so far is targeting outreach, mostly for acquiring new customers. But perhaps the hotter one, depending on your business situation, is actually targeting retention. That is, it's called churn modeling, predicting who's churning, who's leaving, which customers are at risk of losing in order to more efficiently target efforts like discounts meant to keep them around. So you can see this as sort of your basic marketing situation. You've got customer base's balloon, and the churn, the flow of new customers coming in from the left is matched or equaled by, in some cases, the attrition, the leakage of customers leaking out, flowing out to the right. If we could just squeeze that nozzle on the right just a little bit, how much more quickly would our balloon be expanding? That's the growth rate of your customer base. The problem is that getting a customer who's going to leave to stay can be expensive. A retention offer or a discount that you're not necessarily going to extend to your entire customer base. You can't, practically speaking, in most cases. So again, prediction, the only recourse. And that would be churn modeling. You're looking at a customer today, you're saying, should I extend this discount offer? Will it keep them around as a magazine subscriber, or will we lose them tomorrow? So this is the part when we're talking about churn modeling where I'll actually give you a specific, in just this and one more slide, of what an actual predictive model might look like in the case of a decision tree. That's one of the main, most popular modeling methods, relatively simpler modeling method, but also very popular and not only a good place to start for learning about machine learning, but in many projects for executing. So in this case, this is based on data from Chase Bank across mortgage holders and trying to predict which mortgage holders are we going to lose, who are we at risk if they're going to go refinance with a competing bank. In other words, they're going to pay us back too fast. It's kind of ironic. Financial services risk would usually refer to not getting paid back at all. In this case, we'll get it paid back too quickly, thereby losing future interest payments, which is why we're in the loan business in the first place. So just based on the interest rate, whether it's below 8%, it puts us into these two segments with vastly different rates of defection or of attrition. That we're going to lose customers at the rates of 3.8% versus 19% respectively. Huge difference just based on this one variable. Now the point of creating these golden eggs of the machine learning is to figure out how to consider multiple things together in concert. So obviously, for a mortgage holder, you know a whole bunch of things about their home and about them demographically and behavior, their history of payments, and all sorts of stuff about the characteristics of their mortgage. We want to be able to, the problem that machine learning solves, and the same methods apply, whether it's for financial services or manufacturing or whatever. It's the same core analytical methods. And the problem it's solving is how do we combine all these different factors or variables? How do we consider them all together in concert for one individual to render as precise a predictive score as we possibly can for whatever it is we're trying to predict in this project? So in the case of a decision tree, you do that by growing the tree down, upside down, from the top down. We're going to take these two segments and break them down further by the next best variable that does a good job at discerning between risk levels of losing the customer in this case. Right, so here we have grown it down to a certain degree. This is not the optimal tree, which actually was a lot bigger than this, but it's an excerpt of the tree to give a sense. And the way the tree works, once the learning is done and you're deploying or using the tree, for any individual customer, you start at the top, and each one's a yes-no question, and if the answer is yes, you go left. And if the answer is no, you go right. It's always like that, and you get down to the end point, and that's your risk level, the probability, the predictive score for that individual. Right, so this is an example called decision trees, one way to do these golden eggs. It kind of corresponds to business rules. It's relatively transparent. You can understand it with human eyes. Other more advanced methods that potentially predict more precisely become opaque because it becomes sort of a soup of math, tough to understand. So it's a trade-off. There's diminishing returns. It depends on the project. In any case, that's sort of a sense of the kinds of patterns and methods under the hood there. Back to the business case of churn modeling, to finish off that story. In some cases, even if you have a higher chance that this customer is going to leave, trying to get them to stay can potentially backfire. There's a little plot twist here. Let's say, and this is a very popularly done by cell phone carriers, and they'll say, hey, we're going to give you a free device if you'll renew your contract. The problem is that the individual consumer, she feels incarcerated, she wants to change to a competing cell phone provider, and by receiving this retention offer, you're actually reminding her, the light bulb goes on over her head, oh, that means my contract's going to expire soon. I'm free to defect. And you've actually triggered this customer to leave who otherwise would have stayed. And these are called, people often call these sleeping dog customers. So you want to exercise the adage, let sleeping dogs lie. Don't trigger customers to leave who otherwise would stay. And it turned out that the Obama campaign showed exactly the same thing with voters. Some voters were predicted that if a volunteer knocked on their door, you actually decrease the chance of getting a vote for your candidate, increase the chance of getting a vote for the opponent at the time, Mitt Romney. Okay, so before I wrap up and sort of talk about how this stuff is used in so many different ways, let's broaden a little bit beyond marketing, talk for a few slides about applications in manufacturing and automotive. Excuse me. So in a nutshell, in manufacturing, probably the most popular, covered area is in predicting defects, that is, say, triaging, prioritizing, inspection of products or items as they roll off the assembly line. But there's also predicting the overall downtime of an entire assembly line. There's predicting recalls of entire product lines. There's, for predictive maintenance, there's predicting breakdowns, and I'll give you an example of that. And there's predicting demand for optimizing supply chain. And by the way, so for example, at this year's Predictive Analytics World for Manufacturing, which is also June in Vegas alongside our other Predictive Analytics World events, here are some of the case studies covered in those areas from Sanmina, Siemens, Seagate, and others. So for example, the Army does predictive maintenance. They're predicting which of their vehicles are going to break down so they can preemptively do maintenance and inspection and this kind of stuff. I mean, this stuff applies all over the place. Which satellite battery is going to run out faster? I mean, the potentials are, and the actual use cases are growing so rapidly. TTX predicts for each individual of hundreds of thousands of railway wheels, which are going to have a problem, right? And in that case, it's for forecasting overall inventory need. So not necessarily for inspecting the individual wheel, but as a step towards using predictive analytics on the per wheel basis, right? Because that's how predictive analytics operates, per individual. And then rolling it up to create actually a forecast over the overall inventory needs and to get a pretty accurate forecast on how many new wheels they're going to need next year. More broadly than in just manufacturing, the automotive industry's got so many different places that are touched by and improved with predictive analytics. Pretty much your experience as a car owner, it's so many different aspects of it are influenced by predictive analytics. Right? As we move towards self-driving cars, there's lots of intermediate things, predicting collision avoidance, predicting driver inattentiveness, predicting which drivers may be most likely to be reckless. And that also starts to be a lot of these uses in law enforcement are making predictions per individual potential criminals. Predicting traffic delays or undue traffic delays coming tomorrow. There's a case study from Australia doing that, I think around Melbourne. Predicting road safety issues. So the government, predicts which bridges are most likely to have problems. So again, for triaging and ordering the inspection of these infrastructure elements. As cars become more connected, just wireless reliability is a really big area in predictive maintenance in general with cars and beyond that. Cybersecurity, there you're predicting intruders and viruses, and that's going to infect automobiles as much as anything else. Anti-theft, so we start using biometric markers, authenticate, is this the right person sitting in the car, this kind of thing. Also speaks to anti-theft efforts by law enforcement, which neighborhood's most likely to have car theft, so we send patrols there. So many different areas. And then in financial services, both with car loans and insurance, I put a bunch of case studies and comments on this slide on examples with machine learning improving in those areas for car insurance and car loan risk. The Canadian Automobile Association improves their roadside assistance. I'm going to fly by this one. So now more broadly than just in business manufacturing, financial services, all sorts of government applications, law enforcement, healthcare analytics is a huge area, right? In that case, we're trying to optimize treatments, not of customers, but of patients. Same core analytical methods, same value proposition in deployment and operation, essentially. Very closely analogous, it turns out. Our experience in modern society is dictated by how we're treated and served, so the actions done unto us. These verbs on this slide, how, whether we're investigated. And all these companies are making these many decisions a day. Everyone here is affected by predictive analytics every day. More and more companies are jumping on the bandwagon, and millions of decisions a day are determined by the output probabilities from predictive models. Who to call, mail, approve, test, diagnose, warn, investigate, incarcerate, set up on a date, or medicate. That's in the wrap because it rhymes. So I put it in the wrap. I also put click, buy, lie, die in the wrap. Anything that rhymes, I put it in the wrap. Predictthis.org. I hope you're going to watch it? Yeah. Now, as consumers, you can look at this stuff as helping us address the sort of ultimate issue of information overload. So the same core machine learning methods are used to order the search results on Google, to order your news feed of all the thousands of posts in recent times from your contacts on Facebook, to filter spam out of your inbox, and then all the product recommendations, which is another sort of type of information overload. Movie recommendations, books and other products. The search results when you do an Airbnb search are personalized to you, the order of those results. And prospective daters. We even had a presentation at the conference from Match.com. So with all that in mind, I like to call predictive analytics the latest evolutionary step of the information age, where we've moved from engineering of how to collect, warehouse, manage, maintain larger, bigger and bigger amounts of data, to the application of science to learn from that data, its content, what it means, what it's telling us, and learn how to predict. That's the most actionable type of analytics, is to make these per individual predictions because they directly inform that level of detail, that level of granularity, thus being one of the key last remaining ways to improve all the main actions and operations we do as organizations. The Harvard Business Review called machine learning the most important general purpose technology of our era. Famous machine learning professor Andrew Ng calls it the new electricity. So I've talked about so many different applications because what you're doing is learning from data how to make per person or per individual predictions, which render mass scale operations more effective. The value comes from these two effects: the prediction effect, a little prediction goes a long way, and the data effect, which is that data is always predictive. So here's some information I can talk about with regard to getting started and stuff. So thank you for your attention, and let me do a couple quick questions, and we'll just go a couple minutes late if anybody has any questions. So in general, if you want to get started, there's sort of two questions. Are you going to try to get started as a hands-on person, and or are you trying to get started as an organization and figure out what's the next best initiative? Right? So it's sort of looking at any mass scale operation. Where's the lowest hanging fruit? Where's the greatest potential for improvement? Right? What are the costly things? When you're doing marketing, most marketing is false positive. Most people that get mail at their home throw it out immediately. It's junk mail, right? That doesn't mean it's not valuable, but that's the cost. Where can you reduce it? Yes?
Yeah, so you're showing the decision trees. Is there an easy way to output what the decision tree shows? Like when you program it, how do you get that result? How do you show the picture?
Well, the question was how do you get that picture of a decision tree? How do you sort of understand it? How do you output it? So in general, for all these different methods, whether it's a neural network or a decision tree, there's a lot of different software solutions. Some of the vendors out here, like DataRobot, who's also a sponsor of Predictive Analytics World, have solutions. There's open source solutions. And what these solutions do is they take what are a pretty standard set of methods, but then they make it accessible to you. So they wrap it and help it integrate with your systems and your data and how to deploy the methods, and they're going to visualize it in some way or another, right? So that particular decision tree image was drawn by my graphic designer for one of the pictures in my book. If I showed you what it looks like in some of the software tools, it's not it's a little bit more arcane, but it's basically the same thing. So there's different ways to graphically depict it or just output it as text. But what's important ultimately is the concept. So in the case of a decision tree, if you follow it from the top down to one endpoint, the yes-no game, down to any one of those paths is actually like a long if-then statement in English or programming languages. So if the customer is male and has a house worth more than $80,000 or $800,000 and whatever it is, then there's a 35% chance, that kind of thing. So they may be long run-on sentences, maybe relatively arcane, but relatively understandable compared to some of the more mathematical methods. What do I see as the biggest barriers to getting started? Whether you need two main ingredients, once you sort of isolate, oh, this is where there's a big cost point, this is where a mass scale operation could be more effective, there's two main ingredients that you need for the project to be successful. One is you need to have the data from which to learn. To be a bit more specific, you need, in that training data, that list of examples, you need enough both positive and negative examples of the thing you're trying to predict, where it did happen and where it didn't. It's usually a yes-no question for when you start. It often makes sense to start with a prediction goal, which is basically a yes-no, it did happen or it didn't. You can also predict how much or how often, but that tends to be a little more complex. In any case, for example, in fraud detection or direct marketing, you have a very small, relatively small number of positive cases. So you may have plenty of negative examples, and they're all each valuable. What you need to worry about is making sure you have enough positive examples, hopefully at least a few thousand. There's no absolute answer to how many you need. It's a little bit experimental. There's a little bit of hand-waving there. So the first of two ingredients is the data. And the second is that you need to have a potential path towards deployment. The actual operations in marketing, on the assembly line, in the fraud investigation department, whatever's going on right now in your company, people have to be willing to change what they're doing now, or these predictions aren't serving any purpose. So the main pitfall is actually not a technical one, but an organizational one, where there'll be an initiative, do some machine learning, create a nice predictive model that has a good lift, it does pretty well, it's providing potential value, but it's DOA because the organization hasn't had enough buy-in on the operations side, in that management side, on the executive level, whatever it is, to get past the barriers, to pass the inertia, get the buy-in to actually deploy it and have it integrated, have it implemented, have those outputs, those predictions, actually have an effect with an A, on those operations. So you have to use them. So that's the second of the two main ingredients. The first is the amount of data. The second is have a path to deployment, a potential use, and get that buy-in. That's an organizational aspect to the project. So I'll be available during the break for questions. It was great talking to you. Thanks very much for your attention. Thanks.